Okay. So for the 3 dimensions, mahalaga na alam natin yung iba't ibang klase ng supports, no? So una, kapag yung isang member ay cable or flexible cable, okay, ang force niya palaging pahila, okay? So kung ito yung kinukuha nating body, pahila palagi siya. Okay? Pero kung ito ang susundan natin, pag ano naman siya, no? Okay, or pag ganyan. Okay, basta palagi naman siyang pahila. Okay? So wala nang iba. Whether huwag kanyong intindihin kung naka-fix ba siya sa wall, kung naka-pin ba siya sa wall. Basta ang mahalaga, kung cable siya, lagi lang siyang along or parallel dun sa length ng ating cable. Okay? Pangalawa, so yung spherical roller or any surface of single point. Okay? So, this one, para kang, ano pa dito? Pinakamagandang ano niyan is, alam niyo yung kuwari, yung may parang may bola dito. Okay, so pwede siyang umikot. Okay, in short, kung meron kang in 3 dimensions, okay, let's say meron kang in 3 dimension, tapos nakaganyan siya, para siyang lang meron diyang gulong na umiikot. Okay, so it means yung gulong pwedeng mag-move back and forth dun sa, let's say that is X, Y, and then Z. Okay. O pwede ka mag-move back and forth sa Y, pwede ka rin mag-move back and forth sa X. As well as, pwede ka rin umikot. Okay? So, pwede kang umikot-ikot na ganyan. So, in short, wala kang moment. Okay? So, kung pwede kang mag-move dito sa X and Y, so, yung Fx mo, reaction sa X, wala yun. Reaction sa Y, wala din. As well as all the moments, MX, MY, and MZ, lahat yan wala. Ang meron ka lang palagi is the FC. So, yun lang yung reaction na meron ka, nag-iisa lang, okay? And that is always, okay, perpendicular dun sa plane. Okay? Next, itong roller na to, okay, kung iisipin natin, ayan, para siya may ganyan, kapag nakita ka ng ganyan, okay, ang pwede naman dyan, okay, so ito yung mga forces na meron ka. Kasi, okay, para siyang naka-fix dito sa part na to, no? So, hindi mo siya pwedeng i-move ng paganyan. Okay? Pero pwede siyang umikot. Okay? Pwede siyang mag-move ng paganto. Pero hindi siya pwedeng umikot dito sa Y. Okay? So, kapag ganyan, saan nakikita to? Hindi ko sure kung nakapag-ano na kayo, pero sa machine nyo siguro meron, yung sa mga shaft. Okay? So, yung mga umiikot na shaft, kadalasan yan, nakaganyan eh. Okay? Tapos dalawa minsan yung shaft. Ayan, let's say meron kang shaft na ganyan. Okay? So, ito, pwede siyang umikot. Okay? So, umiikot siya. Okay? That part, okay? Hindi ka pwedeng mag-move dito sa direction na to. Okay? Naka-fix siya doon. So, pero pwede kang umikot. Okay? So, ang reaction naman doon, dalawa. Isang normal force at isang force which is, okay, parallel dito sa direction na to. Okay? Yung pang-apat, okay, ito yung ball and socket. Okay, itong ball and socket, pinakamaganda namang example nito ay yung tawag dito, para sa bangko ka, may fill up ka, no, yung mga nagbabank siya. Minsan may ballpen doon. So yung ballpen na yun, di ba? Pinaglalaroan pa minsan ng paganyan eh. Okay. So yung pinaka-ball na yon, hindi siya pwedeng mag-move in any direction. Translation ng tawag, okay, hindi siya pwedeng mag-move, pero pwede siyang mag-rotate. Okay, pwede siyang umikot-ikot. So, kapag ganun yung support mo, tatlo naman siya, puro siya forces, MX, MY, and MZ. Okay? Okay. Kapag meron kang friction, okay, kung papansinin nyo, ito, at saka ito, almost magkamuka. Except that ito, frictionless yung surface. Halimbawa, nasa ice. Okay? Pero ito, nakapatong naman siya sa magaspang. Ibig sabihin, meron kang friction, okay, let's say sa mga kalsada. Okay? So, meron siyang friction. Kapag meron kang friction, tapos nakapatong yung isang bagay, tatlo din yung kanyang reactions. Okay? So, hindi ka pwedeng mag-move in any of the directions. Okay? So, ayan. Ito, meron din pala to. Ito yung sinasabi ko kanina. Okay, hindi ka pwede kang umikot. Okay, dalawa rin yung reactions nito. So we have here on this direction and then on that direction. Na, ito, I do not know, ito yung sa mga hinges ng pinto. I don't know kung ginagamit nyo to sa machine nyo, okay? Sa hinges ng pinto, okay? Kasi pag ganito yung force mo, okay, hindi ka mag-move dyan. So, basta meron kang restraint. Ibig sabihin, pag hindi mo na move doon yung isang body, ibig sabihin, meron kang reaction doon. So, ito daw yung Y, okay? Ngayon, yung pinto, hindi mo rin naman pwedeng iikot pataas, ano? So, meron ka doon. Okay. Ito, hindi mo na rin siya pwedeng i-move pag ganun. So, kaya meron ka ring reaction doon. Kaya tatlo yung reactions mo. Okay. Now, yung sa machine nyo, okay, kung meron kayo sa mga shaft na ganyan, kapag hindi na move ito, okay, so ibig sabihin, ng pag ganun, ibig sabihin meron ka ding reaction doon, ano? Basta yung isang body is hindi na move on a certain direction, ibig sabihin may restraint. Pero kapag na-move siya, ibig sabihin wala siyang restraint. Okay? So, ganun siya. Ito, bihira naman tong gamitin natin. And hindi pa nga ako nakakita yata sa personal nito. Okay? So, 4 dyan, may isa. Okay. Pero kapag fully fixed ka, okay, kapag iya sinasabing cantilever support, kapag fully fixed ka, lahat forces meron. Fx, Fy, Fz, Mx, My, and then Mz, or couple. Kaya dito, Cy, Cx, Cy, and Z, or moment. Ano? Okay. So, those are the common supports na meron tayo. And then, ang mahalaga lang is how to draw the free body diagram. Okay. So, ito, for example, itong free body diagram, ano? So, yung 20-pound surveyor's transit daw. Okay. So, alam nyo ba yung transit? Oo. Pag nakikita nyo yung mga civil dati na parang may camera, so, yun yung transit, ano? Nagsusukat yun ng lupa. Anyway, so kahit ano man yan, whether it is transit or a machine, so basta 20 pounds, supported by the tripod of negligible weight. Okay? So the legs of the tripod are connected by a ball and socket. So ibig sabihin, yung ball and socket daw, pag ball and socket, tatlo, no? On the platform. Draw the free body diagram. Okay. So yung free body diagram yan, parang i-drawing mo lang yan lahat. And then ito, syempre, meron kang weight doon. Lalagyan mo lang yun ng weight. Okay, so let's say 20 pounds. Okay. And then, tatanggalin natin lahat ng reactions. So, lahat ng reactions, papalitan natin ng forces. Since tatlo yung reactions, ball and socket, so meron ka ditong, sabihin na natin, in BX, BZ, RBZ, okay, and then tatlo rin dito, saka tatlo doon. Okay, palaging pag ganyan, ano, kasi ball and socket siya. Okay. So, para lang alam mo yung free body diagram ng mga forces mo. Okay? So, ganyan lang. Yung sa pagdodrawing lang to ng free body diagram. Okay? So, ganito lang siya. So, yung solution, pinakita lang yung tatlong free body diagram. And then, sabi natin, okay, kapag parang, di ba kapag sa thrust natin, kapag yung dalawang dulo, okay, kasi ito, makukuha mo yung pinaka-resultant. Kapag yung dalawang dulo is pin connected, tas wala kang ibang forces, nasa dulo lang yung dalawang force, palagi yung ang force nun is parallel doon sa ating length. Okay? So, kaya yan, yung PB niyan, makikita nyo, parallel dun. Ito rin yung PC, yung pinaka-resultant nito, parallel dun. And then ito, parallel din dun. Okay? So, that is 2-4 system and 3-4 system. Ano? So, ito. Practice problem. I-draw nyo lang yung free body diagram dyan. Okay. So, dito tayo sa pinaka independent equilibrium equations. So, 6 siya. Forces. Kapag nag-resultant tayo, MX, M1, MJ, and 0. Okay? So, concurrent forces muna tayo. So, meron yung iba't ibang forces. Okay. Ito yung mga iba't ibang klaseng forces na pag concurrent, tumatama sa isa. Kapag parallel, tumatama sa iba-ibang points, pero they are parallel to each other. Okay? So, iyon yung atin different force system, no? Okay. Solve tayo. Ayan. Let's try this one. Calculate the tension in each of the following, in each of the 3 cables that support 1,500 kilonewton weight using the given free body diagram. Actually, given ng free body diagram, pero pwede naman tayong gumawa ng free body diagram natin. Ano? So, pinakamaganda niyan, alam dapat natin yung pinaka force, kung paano mag-force. Since this is a cable, alam natin na ito, magkakaroon ako doon. Okay, tawagin natin siyang tension sa AC. And then ito, pwede natin siyang tawaging tension at AD. And then ito, pwede natin tawaging tension at AB. Okay? And then meron kang weight na 1,500 kilonewton. Okay? So, actually, pwede niyang free body diagram na ganyan as long as alam niyo. Okay. Next. Para makukuha tayo, okay, kailangan kunin natin yung coordinates. No? Coordinates muna ng A. Yung coordinates ko ng A, sa X niya is negative 2. Okay. So, Y niya ay 0. And then sa Z niya is negative 2.5. Okay? Next, when it comes to B, so this is negative 2. Sorry, 0 pala yung X dito. Okay, 0. And nasa line ng X, ano? So, 0, 0, negative 2.5. So, it is negative 2, 0, and then 0. Next, yung C, we will be having here 3. So, Y is negative 1.2. And then sa Z is 0. And then for the D, we can have it for the X, 0. For the Y is 1.5. For the Z is 0. Okay? Ngayon, ang gagawin natin, i-represent natin yung kada forces into vector form. Okay, unahin muna natin for TAB. I will have it for the T or tension at AB. Okay? So, kailangan muna natin makakuha si RAB. Okay? So, RAB, so negative 2 minus 0, negative 2i. 0 minus 0, minus 0j. 0 minus 2.5 plus 2.5 of k. Okay? So, we can have it also the RAB. Okay? So, yung ating RAB, so square root of 2 squared plus 0 squared plus 2.5 squared. Okay? So, you have here 3.201. Okay? 202. 202. Okay? Now, to have it for the unit length, our unit vector, we can have it as lambda AB. So that is RAB all over RAB. Okay, so that would become equal to, okay, negative 2 divided by, so negative 0.625 of I plus 0j. And then plus, so we can have it 2.5. 0.781 of K. Yan. Okay? So, in short, yung ating TAB, so that would become equal to TAB is equals to TAB, okay, multiplied by the lambda AB. Okay? Or that's around negative 0.625 TAB of I plus 0j plus TAB of 0.781 of K. Okay? So, meron na tayong TAB. Okay, next. We will be having as TAD naman. So, for TAD, kunin muna natin si RAD. Okay? So, for the RAD, 0 minus 0, 0i. 1.5, laging head minus tail. So plus 1.5 of J and then plus 2.5 of K. Okay? So we can have it as RAD equal to square root of 1.5 squared plus 2.5 squared. Okay? So we can have it as 2.915. Okay? So we can now have the lambda AD. So lambda AD is RAD all over RAD. So we can have it at 0i. Okay, 1.5 divided by 2.915, 0.514 of J plus, 2.5 divided by A plus 0.857 of K. Okay? So that yung ating TAD in vector form, so that would become TAD and then multiplied it by the lambda AD. Okay? Or that's equal to 0i plus 0.514 TAD D and D of J plus 0.857 of TAD of K. Right? And lastly, we can have it for the TAC. So TAC, kunin muna natin si RAC. So that is 3i minus 1.2 of J. Okay, and then plus 2.5 of K. So we can have it the RAC equal to square root of 3 squared plus 1.2 squared plus 2.5 squared. 2.5 squared. So that's 4.085. Okay? So we can have it the lambda AC. So that is RAC all over RAC. So equal to, so 3 divided by the, so 0.734 of I minus 1.2. So minus 0.294 of J and then plus, we will have it 0.612 of K. Okay? So that, we will have it as TAC equal to 0.734 TAC of I minus 0.294 of TAC of J plus 0.612 TAC of K. Yan. Okay? So take note that this one, lahat yan is the X component. Ano? Okay. May isa pa pala, yung weight. Ano? So, pwede natin yan yung weight. Yung weight natin, okay, pag nilagay ko dyan, 0i plus 0j, then minus 1,500 of K. Okay? Kasi directed downward siya. Okay. Now, ngayon, ang gagawin natin, magsasummation forces X tayo. Equal to 0. So, yung X component nito is negative 0.625 of TAB. Okay. Para dito, 0 of TAD. TAD yun eh. And then we can have it ito plus 0.734 of TAC. Okay, plus 0 equal to 0. Okay, so we will have it first equation. So, iyan ko na. Ilipat ko sa kabila, parang 0.625 of TAB plus 0 TAD plus 0.734 TAC equal to 0. You will have equation 1. Okay? Summation forces Y equal to 0. So we can have it as 0 TAB. Okay? And then you will be having here plus 0.514 TAD. Okay? And then minus 0.294 of TAC. Okay? And then equal to 0. Wala naman eh. Okay? So you will be having here equation 2. And lastly, you will having summation forces at Z equal to 0. So that is 0.781 of TAB. Okay? Plus 0.857 of TAD. Plus 0.612 of TAC. Okay? Minus 1,500. Ilipat ko na sa kabila, ano? So, kaya magiging equal to 1,500. Dapat yon minus 1,500 equal to 0. Pero kapag nilipat natin sa kabila, so that is equal to 1,500. Okay? So, equation 3. So, 3 equations, 3 unknowns, solving simultaneously, kaya naman ang calcu nyo. Okay, hayaan ko na kayo mag-calcu. So, negative 0.625, 0, 0.734, 0. Then, second line, second equation, 0, 0.514, negative 0.294, then 0. Third equation, 0.781, 0.857, 0.612, 1,500. So, solving, you can now have the value of TAB. And that's equals to 872.34 kilonewton. And then we can have it as TAD equals to 424.87 kilonewton. And lastly, we can have it as TAC equals to 742.80 kilonewton. So these are the forces on the cable of the tree. Question. Question?
Sa coordinates ng B, negative.
Alin ba? Coordinate ng? Yeah. Sorry. Baliktad tayo, no? Thank you for that.
Bali po, baliktad po.
So, ito naman ay magiging negative 3. Okay, so check natin. For the record, yan ako, no? Para alam natin, okay, wala naman palang pula. Okay, so this should be positive 2. Para ito ay tama, so ito lang ay magiging positive. Okay, so ito ay magiging positive. Okay. On that, this would become positive, and then that would become positive. Okay, next sa TAC. Okay, dito tayo. So, that is negative 3. So, okay naman to. Ito lang ay magiging negative. Okay, 0.734. So, negative 0.734. Okay, and then that would be this one. Okay, negative and then negative. Okay, so let's check. So that is positive 0.625, 0, negative 0.734, and then 0, 0, 514. Okay, let's check if changes. So, okay ito. Okay. Still okay. Okay? Parehas lang kinalabasan. Bakit kaya sa tingin nyo? Logically, bakit? Same lang yung kinalabasan. Naging consistent yung pagkakamali. Ano?
Sa science lang.
Okay, nagkabaliktad lang yung sides, pero consistent naman siya. So, parang dito naging positive, doon naging negative. Okay? So, nagkataon lang yun, ha? Pero mali yun, ha? Mali. Kasi, kapag nagkaroon tayo ng right thumb rule, magkakaroon yun ng negation. Okay? So, good observation. That's correct. Question? Okay. On the handout na ibibigay ko, Okay, meron dong isang method gamit yung moments. Okay. Ang ginawa niya, okay, ang gagawin dito, ito pala. So, you can have it as, tama ba yung sagot natin? May ano naman pala. Ayun. So, TAB, 872 or 873. TAC, 743. And then TAD is 424. Okay. Now, this is how, ito yung pinakamadali para sa akin, So, merong isang method. Okay, so kung saan isang method ang ginawa niya, nag-moment siya sa line na to. So, you may do that. Walang problema. So, you take this line. Bakit siya nag-moment dyan sa line na yan? Para kasi dadaan dun yung dalawang unknown force. So, dadaan si C, dadaan si D. So, itong dalawang force natin ng TAC and then TAD, wala nang moment yon. So, ang may moment na lang doon is itong TAB at itong 1,500. Okay? So, ang ginawa niya, magmo-moment siya, summation ng moment sa line CD para makuha niya si TAB. So, ganito ginawa niya. Nag-moment siya sa line CD. So, RCB cross product. So, yung RCB natin mula dito hanggang doon, parang kumuha siya dito. Okay, dito siya nag-moment at this point, RCB, para i-cross product niya sa TAB. Kaya lang, since this is a line, so parang yung lesson natin before, kailangan naka-dot product siya dito sa unit vector ng line na to. Kaya meron ganito. Okay? So, ito yung moment ng TAB along the line CD. Plus, yung moment ng weight along the line CD. CO naman siya. So, kasi ito, ginawa niya dito na lang sa CO. Kasi tatama naman yung line of action doon, So, ay, kumano. Tatama naman kasi yung line of action ng force dito. So, ito yung ginamit niya. RCO, cross product ng 1,500 for the weight. Kaya lang, since ang kailangan natin isa line na to, kailangan naka-dot product dun sa unit vector ng line na yun. Okay? So, ito lang yung working equation and then the rest is mathematical kung paano natin ginawa. So, parang triple product lang to. So, you may solve for the TAB. Okay? So, same procedure. Okay? Kung gusto nyo hanapin naman yung itong AD, dito ka naman magmo-moment. Okay? Tapos yung the rest, yung isa naman. Okay? So, kayong bahala kung saan kayo mapapadali. Question. Sa mga previews, may tanong ba? Wala. Paano kasi yung iba hindi pa pinapanood Hindi pa nag-aaral kaya wala pa talaga matatanong. Okay? Huwag niyong ugaliin kasi madadagdagan at madadagdagan. By next week, we will proceed with the friction already. Okay, tutuloy lang natin to ng kaunti, pero aabutin na natin yung friction. Remember, it's already almost 3rd week of January and magpa-finals na kayo. Kailangan matapos natin hanggang moments of inertia. Okay? Anyway, yung friction, medyo natakal nyo na yun ng physics. Parang grade 6 pa lang yata, pinag-aaralan nyo na yung friction Okay, so paulit-ulit lang naman, mas umirap lang ng kaunti ngayon. Mas marami lang forces na kinoconsider. Question. Wala. Sigurado? Sige. Hindi ko na pagtatagalin kasi actually, dun sa sinend kong videos for this week ng sections, 3 oras na yun. So, 3 hours class lang tayo. Meron na tayong IL kung nabanggit na sa inyo yun. Kaya na-compress tayo Meron tayong IL. Yun yung independent learnings. So, that's around half an hour din. So, 36 minutes to be exact. So, nakaka 32 minutes tayo. So, hanggang dito lang yung ile-lesson ko sa inyo. Okay? If you have question, okay, para sa class nyo, maganda ganito gawin nyo, So, kung may time kayo, kasi last hour naman yung hinihingi kong time lang sa inyo, yung yung first 2 hours ng klase nyo, since wala naman kayong ginagawa nun, dun kayo mag-aral ng mga videos na na-accumulate nung nakaraan. Okay? So, para naman makapag-aral kayo ng mabuti. Wala nang question? Sige. Kung wala nang question, I'll just upload the videos on the group, on the Google Classroom, and see you by next meeting, next week.
Thank you po, sir.
Thank you po.
Thank you, sir.
Thank you po, sir.